Hello friends, welcome to engineering tutorial. In today's video we are going to discuss some problems on calculation of equivalent inductance. So we are first going to start with a simple circuit related to inductance, and then we will gradually move on to little bit complex and tricky circuits. So first, here you have this question. Okay, it is a circuit which consists of you can see 4 inductors of inductance is 2 Henry, 4 Henry, 4 Henry and 1 Henry, which are connected in this way, and we have to find the equivalent inductance in between points A and B. Okay, so you can see these two inductors 4 Henry and 4 Henry, they are connected in parallel. Okay, they are connected in parallel. So the equivalent inductance of this portion, okay, this portion can be written as L equivalent is equal to 4 into 4 by 4 plus 4. Inductors and resistors, they have the same behavior, they have the same formula when it comes to their equivalent resistance formula. Okay, the equivalent resistance calculation formula for resistors and inductors is the same. Okay, so it is L1 L2 by L1 plus L2. Okay, so that formula, so it is equal to 16 by 8, which is equal to 2 Henry. So the equivalent inductance of this portion is 2 Henry. So now we can draw this circuit as like this. Okay, A and B. This we calculated the middle portion as 2 Henry. This is 2 Henry which was given, and this is 1 Henry. So now you can see these three inductors, they are in series connection. Now I have already told you that whenever there is an end-to-end connection pattern, means the one extreme end, means the right end of one inductor is connected to the left end of the other, and such a pattern is repeated, you can say that the inductors or the capacitors or the resistors, they are connected in series. And when two ends, the same two ends, let's say the left end of these two inductors are connected at one point and the right ends are connected at one point, then they are said to be connected in parallel. So here it is simple, we just add all the inductances, so we get the equivalent inductance across point A and B as 2 plus 2 plus 1 Henry, which is equal to 5 Henry. So the equivalent inductance across point A and B is 5 Henry. Now this is a simple problem. Okay, so after this we are going to discuss some little bit more lengthy circuits which involves more inductors, and they are connected in a bit confusing way. We will discuss those questions. Okay. So this is the second question, okay, so which we are going to solve related to equivalent inductance. Okay, so here we have more number of inductors. Okay, so in total we have 1, 3, 4, 5, 6 and 7 inductors. Okay, having inductances 1 Henry, 2 Henry, 3 Henry, 6 Henry, 8 Henry and 16 Henry. So in these kind of circuits, first we have, what we have to do is that you pick certain combination of inductors, try to reduce them, and then gradually try to reduce the circuit. So here first what we are going to do is that we see these three inductors, 2 Henry, 3 Henry and 6 Henry, this combination of inductors. These three inductors, they are connected in parallel. Okay, these three inductors, they are connected in parallel. So first we will try to find the equivalent inductance of this portion. Okay, so let us just find the equivalent inductance of this portion. So the formula for equivalent inductance for inductors connected in parallel is 1 by L equivalent is equal to the reciprocal, the sum of the reciprocals of the individual inductors, 1 by 2 plus 1 by 3 plus 1 by 6. Now 6 is the LCM, this is 3, this is 2, this is 1, which is equal to 6 by 6, which is equal to 1 Henry. Okay, so the equivalent inductance of this combination of inductors is 1 Henry. So let us just redraw the circuit. Okay, so we calculated the equivalent inductance of these three combination of resistors which are connected in parallel as 1 Henry. Now A and B. So this is 1 Henry, this is 1 Henry which we just calculated, and this is 6 Henry, this is 8 Henry, this is 16 Henry. Now look at these three inductors, 1 Henry, 1 Henry which we just calculated, and 6 Henry. These three inductors are connected in series in an end-to-end pattern. So the equivalent inductance of this combination of three inductors, 1 Henry, 1 Henry and 6 Henry, which are connected in series, is simply the sum of the individual inductances, that is 1 plus 1 plus 6, which is equal to 8 Henry. So let us just combine them together. Sorry. So this is 8 Henry. What we did is that we just combined the three inductances, 1 Henry, the equivalent inductance 1 Henry and 6 Henry. We got the total inductance of that combination as 8 Henry. Now look at these two inductances, 8 Henry and 8 Henry. They are connected in parallel. So now we will calculate the equivalent inductance of these two inductance combination. Okay, so that will be L equivalent is equal to 8 into 8 by 8 plus 8. Okay, so that will be 64 by 16 Henry, which is equal to 4 Henry. Okay, so the combination, the equivalent inductance of this combination is 4 Henry. So let us just redraw the circuit again. So we'll just simply remove this portion and this will be 4 Henry. Okay, now this 4 Henry and this 16 Henry, they are in series. Okay, this 4 Henry and this 16 Henry, they are in series. So the total inductance across the point A and B, now we can write it as the sum of these two inductances, which is equal to the total inductance between A and B is equal to 4 Henry plus 16 Henry, which is equal to 20 Henry. So you see how we just picked a certain portion. Okay, we picked a certain portion in the circuit, we solved it, we reduced it, then we gradually solved by identifying patterns of connection. See, the first thing which, when you look at this circuit, the first thing which must strike your mind is that these three inductors are connected in parallel. So let us first reduce them together and convert them into one inductance by calculating the equivalent parallel inductance. Now after calculating that, this three inductors, 1 Henry, the resultant of the this 3 inductance and this 6 Henry, they will be connected in series. So then you reduce that and convert them into 1. Then that inductance and this 8 Henry inductance will be in parallel. So you convert that and reduce them into 1 inductance, and then finally this 4 Henry, which was the equivalent inductance of this portion, okay, this portion is 4 Henry, we added it with 16 Henry to calculate the total inductance as LAB equals to 20 Henry. Okay, so this is another problem related to calculation of equivalent inductance. So we will solve some more problems, okay.